Hi, everybody. This is Dr. Robyn MacKillop with Get That GED, and today we are going to continue studying physical science, which today I think is mostly chemistry. So we will check it out. I'm going to share screen. All right, can you see that okay? The structure of matter.
Yes,
Awesome.
thank you.
So again, you've got 3 paragraphs. Don't read them if you don't have to. Wait until you get to the question to find out if you need to read. So we come down to the question, based on the model, which statement describes a helium atom? So they're talking about the image. We don't have to read. Whatever we need is going to be in this image. So we'll check A. A helium atom has more protons than electrons. Here's a key. The proton is blue. The electron is yellow. Same over here. Helium has 2 protons, 2 neutrons, the green, and 2 electrons, the yellow. So a helium atom has more protons than electrons. That's not true. It has 2 of each. So A is out. The nucleus of a helium atom contains protons, neutrons, and electrons. So the nucleus is in the center, and these little guys, these electrons are not part of that. So B is no good. You can get rid of B. The number of protons in a helium atom is 4. So again, we're looking for the yellow. We only have 2. So C is not true. That means D has to be the right answer, right? It better be. A helium atom has 1 more proton than a hydrogen atom.
Yes.
Yep, perfect. We've got 1 and 2, so it is D. And you did not have to read this. 3 paragraphs. That will save you time. All right, let's take a look at molecules. And I'm going to rescan this. I sent this one to you all, and I didn't realize it had a big old stripe down the page. So I'm going to rescan them and make them cleaner, and I'll send it to you again. All right, again, we've got a paragraph. We're going to wait to see if we need to read that paragraph. Based on the illustrated model, we don't have to read for this one. What happens to electrons when 2 atoms form a covalent bond? Now, if you're concerned about covalent bonds, they don't even, do they talk about it up here? When 2 or more atoms share their electrons in covalent bonds, they form a molecule. So this is what we're talking about. This was, think to our chemical equations when we had one element plus another element turned into a combined element. That's kind of what's happening here. You've got your individual element. When they combine, they form something new. So based on the model, what happens to electrons when 2 atoms form a covalent bond? What happens to our electrons? Those are our yellows.
Together.
They stay the same, don't they? We've got 1 here, 1 here. Those 2.
Separate
Yeah.
others together.
Yeah, they stay the same. So A is your answer. And when you find that A is your answer, you don't need to look at B, C, D. Only look at them if you're not positive. But if something's really clear and it's A, you're done. Just move on to the next problem. All right, let's check number 3. Why is it clear that the atoms represented in the model are hydrogen atoms? A nucleus is located in the center of each. Each atom has only 1 proton. In each atom, the electron moves around the nucleus, or only hydrogen atoms join to form molecules. This is a periodic table question. Remember how, do I have a periodic table handy? Shoot. How they're numbered, it starts with helium at number 1, and then it goes to, I think, well, it starts at hydrogen, number 1. Helium, I think, is number 2, something like that. Anyway, the atomic number for each element is equal to the number of protons. That's one of those little things you put on your list of things to remember, because that could be a question. And so that little number at the top of each box on the periodic table, same number of protons. And in this case, we're talking about hydrogen, which is number 1. So which answer is it going to be?
Each atom only one.
And so we know those are 2 hydrogen atoms that came together. And that's another way, that's a way they could do a question on the test. They could give you an image like this with a certain number of protons, and they could ask you what it is. But at the same time, if they're doing that, they'll give you a piece of the periodic table. You do not need to memorize the periodic table. So they'll give you enough information for you to answer it. You don't have to pull it out of your head thinking, oh my God, I should have looked at that more. I should have memorized it. You do not need to memorize it. All right, chemical compounds. Again, we're going to skip the reading. We were able to skip the reading over here too. This is good. What atoms make up the ammonia molecule? So here we have got a big green and 3 whites. And this is the ammonia molecule. So which one makes the most sense?
D.
Yep, perfect. 1 nitrogen atom and 3 hydrogen. I really hope you get questions like this with these images, because you'll nail them. I hope they give you a whole bunch, because you'll fly.
Miss Robyn, we need to know how to read the pictures too.
Ah. So back here on the image for 2 and 3, they're good about showing you that these are 2 individual atoms. They don't really give you a lot of information about what it is unless you read. And they do say in the reading, these are each hydrogen atoms. And then when they come together, they end up sharing the 2 electrons, 1 from each. So, but during the test, you don't necessarily need to know that it's a hydrogen atom other than what they say in the question. And that's why I say you can skip reading this. When you're studying, I would read them, but when you're testing, I wouldn't read them. And this guy right here, a little clearer. But as soon as they said what atoms make up the ammonia molecule, you know this is the ammonia molecule. And it's 1 green atom and then 3 white, 1 nitrogen, 3 hydrogen. Also something you do not need to memorize. If they ask you these questions, you'll get an image much like this. All right, we saw this once or twice, whoops, where they did the chemical formula in letters. And again, I don't think we're going to need to read. Based on the structural formula, what is the chemical formula of ethane? So this is ethane, the one they give us. And they want us to tell them what it looks like in symbol form. Which one did you say? Yeah. I'm going to make that a little bigger. See if it's easier to see. Yeah, it is B because you have two C's and 1, 2, 3, 4, 5, 6, 8. And I hope you get a bunch of these too, because you can hit these out of the park in seconds. A really good way to gain points. All right, here's another, and science loves the images, which is kind of nice because sometimes it makes it easier to figure out what they're talking about. So let's take a look at states of matter and molecular spacing. And we know that matter comes in different states. We have solids, liquids, gases. And if you're dealing with water, water is water, whether it's frozen or in a glass, or steam. If it's been boiled and it turns into steam, it's still water. You melt the ice cube, it's water. If you decondense the steam, it's back to water. So the changes between solid, liquid, and gas for water are physical changes. The item itself does not change. It's water no matter what, but it looks different, it feels different. Physical change. And this question, based on the visual, how does the spacing of molecules compare in solids, liquids, and gases? So they're showing us here a solid, the molecules are packed together, which makes sense because if you have a solid, use a calculator, they don't spread out. All the molecules are within this space. So they're pretty well together. If you've got a liquid, they move around a little bit more. And that would be like your water. You know, it's the same amount of water, but you can move it around a bit. It's got a little more freedom than a solid. And then gases can be all over the place. And that's how you smell things first, because those molecules just go all over into the air. So
Is A.
Gases have the least space for molecules. Or now this is gas. This third one.
Yeah, is in A. Is in A.
I don't think so.
It is actually C. Oh, that didn't work, did it? Ugh.
Because they are asking, the first one is wrong because they say the gas has the least space. No, they have the much space.
Yeah. And in a solid, they're really close together because they have no room to move.
They didn't give answer for the gas. They just mix up.
Yeah. And so gas,
They're asking which take the least space.
Gas has more spaces.
right. Gas has more space. And what do they say? They gave you least.
They didn't tell you more space.
B.
So liquid doesn't even have the most space. Gas has the most space and they don't give us that one. But
That's
solids have the least. They're pretty packed together, and that would be C. Does that make sense?
Confusing.
It can be. And that's why things like this are good to have, because it'll help you get used to the images as well. And I don't love it when they do this, least, most, least, most.
Yeah, least and most make a mistake if you
Yes.
don't understand the sentence exactly what they mean.
Yes, they are very good at writing answers that will pull you to the wrong one.
Yeah.
They know what they're doing.
Just from a small one.
Yeah. Unfortunately, GED likes to mess you up.
Yeah.
Lucrative for them to have you take the test multiple times. It gives them a lot of money. And that's, that's the American way, isn't it? Ugh.
But in Connecticut is free.
Nice. Which state are you in?
Connecticut.
Very cool. I believe the GED in New York is free, and Alabama or Mississippi.
I just paid the registration fee, okay, for the one time only.
Oh, excellent. Yeah, I
And-
wish it was free across the board because it was a government test. So you shouldn't have to pay for it. It's now private. Pearson Learning owns it.
In
they-
Boston, they say it's free too, but you have to be in adult center.
Ah, okay.
You should be there. Yeah.
It's
If you-
I think it's expensive in Oregon. It's 38 in
It was
Oregon.
almost $32.
Wow.
But if you just study by yourself at home, they don't pay for you. You have to be in center.
Of course.
That's still good. Because
Yeah.
every country have different rules. Here you have to pay for the space as well, where you give the test.
Is yours 75 a test, Sultan?
No, 75. Yeah, 75 for test, but there is also like you going for a test center, you have to pay for that. You
Wow.
don't have, yes, you can't go without a center. You have
Wow.
to take a price center and then you have to give the test.
Sheesh.
That's mean
It's-
you have to pay what they're asking, like you can say almost around, you can say 400 to 500 more dollars.
Wow. And your social studies is mostly American history, isn't it?
Yeah. Yeah, it doesn't matter which history you know, you have to know that. Like,
Wow. Yeah, that's spendy. That's a lot of money. And the testing center as well. That's crazy. All right. Here you will not, well, actually, I take that back. You could have some fill-ins on the test. They won't be quite like this. It's usually a number. I don't think GED ever has you write a sentence as a fill-in. But if they were wanting you to calculate something, they might have you put the number in. So this isn't really what you'll see on the test, but we'll look at it anyway because it's about changes in state. So number 2, according to the diagram, to melt a solid into a liquid or to evaporate a liquid into a gas is energy added or released. So we're looking at from a solid into a liquid, is that more energy or less?
More?
The
More.
arrow go up.
Perfect.
The
Yep.
arrow go up.
Perfect.
It's
And
going up.
that is added for that one because liquid to a gas still arrow more energy. If enough energy is removed from a liquid, so energy going
Down.
down, what change of state occurs? What do you end up with?
Liquid to solid.
Perfect. Liquid to solid. Perfect. And then the more energy in matter, the faster the particles within the matter move. Based on the diagram, in which state of matter do molecules move the fastest? So more energy, where are molecules going to really move?
yeah, okay.
Gas?
Yeah, perfect. And that kind of goes with this image. This one is the gas. They have more room to move around so they can move faster. Whereas a solid, just like if you were looking at your calculator, those molecules don't move. They are packed in tightly because they're creating something. And, our calculators don't melt unless we leave them in the sun or something. And that would be a chemical change. All right, let's check out, heating curves. And this is why we'll do velocity and motion next week, because this is walking us right into it. And I think I needed to do some questions on the periodic table. I might make a video for that. Just a couple things to know about the periodic table, no matter what. All right, so here we have, and again, we're not going to read unless we have to. Melting and freezing points occur at the same temperature. So liquid water freezes to become ice at what temperature? So we're looking at,
Zero.
yep. Yeah, melting and freezing points occur at the same, yep, perfect,
Three.
perfect. And then properties of matter. Let's see, can I get the whole thing on here, please? Let me, yep. All right, again, we're not going to read unless we have to. Based on the information in the table, which compound boils at the highest temperature? So you're going to look for in the table boiling right here. Which one?
The number 5,
Yes. This magnesium
magnesium
chloride.
fluoride.
And that'll be D. And I really, seriously, I hope you get a bunch of these, because these you can whip out really quickly. All right, let's take a look at, not that one. You can look at that one on your own. Oh, wait, let me look at that again. Maybe we need to do it. See, a scientist investigates the properties of substances to determine which are metal and records observations in a table. As a scientist would, mark an X in the appropriate place on the table to identify any substance that is a metal. This one likely needs a little bit of reading. So a question like this would kind of force you back into the paragraph. And what you want to do is, you're looking for metal. So skim this looking for metal. Just kind of go down the middle and see if you see the word metal. And it right here. Most metals can be pulled into a wire or flattened into a sheet. And most conduct electricity and heat as solids or liquids. So we come over here to the properties. Does not conduct electricity well. So that's not a metal, right? Because metal does conduct electricity.
Yeah,
Then we look at B.
C.
Gray conducts electricity and heat. That's a good one. That's a metal. So we would X.
C2.
Yep, conducts electricity and heat. And then D does not conduct electricity. So that's not going to be a metal. So you would mark B and C. Nicely done. So that's a good example of where you're going to have to check the reading, but look for the main word. They wanted to know about metal, so look for metal. So you don't actually have to read the entire thing verbatim. All right, let's take a look
How
at.
can you select 2 answers for the one? They asked for one. You give the 2 answers.
Say that again.
I'm telling you, like they're asking about the metal, but you select 2 options like B and C both.
Yeah, if they did that, if they did something like this, they would actually have you mark it. They'd have you point your mouse to each one and click. So they'll set it up so it makes sense.
So then they can give you as well like this, a 2 answer, one or 4 answers.
Yeah.
But the answer will be B and C, both of them.
Yes.
And have to select both as well.
And they'll make it so you can do that if they have more than one answer. They would probably have this table, and then there'd be the ability to click, and either it would highlight or it would leave a dot. So yeah, if they ask for something, it's got multiple answers, They'll have it set up so you can easily do that. You won't even have to think about it. All right, let's do extensive and intensive properties. All right, we are looking at which property changes with sample size. So extensive properties are mass, volume, and length. So mass is weight, how heavy or how light. Volume is everything inside. So if you've got a bottle of water, the volume of a regular bottle of water is something like 16.9 fluid ounces. And so that's the volume, how much is inside, how much it holds. And then length, of course, is the size, you know, if you measured it. So which property changes with sample size? That means if you have more of something, what changes? Does the hardness change?
Melting.
If there's more of it, does that change the melting point? Oh, and this is another example of footnotes. Look right down here. Yeah, properties that the one asterisk is up here with extensive. Properties that change depending on sample size. Or the double asterisk, properties that do not change depending on sample size. So we want to know which one changes with sample size. That means it's going to be something within extensive properties. And hardness is not mass, volume, or length. Melting point is not mass, volume, or length.
How about length?
Yeah, length. That's
Hey.
perfect. Nice. All right, and then we've got chemical properties. And again, this means something has changed. So when water freezes or is at room temperature or is boiled, the water itself doesn't change, but the physical property changes.
Yeah.
A chemical change is when if you put, let's say you put vinegar and baking soda in a little container, that's going to be a chemical change. Does anybody know what happens if you do that? And you shake?
Yeah. So you always, when I clean up something, so I put soda and
Soda.
vinegar
Like you
on my stove.
Yep, you'll be cleaning up for sure. And
Yes.
it changes. It's no longer vinegar and baking soda. Now it's a new compound and it's also explosive. That is a chemical change. So based on the information from the passage and the table, we have not read it. Which statement supports the conclusion that a chemical reaction occurs when silver tarnishes? Solid silver can become liquid silver. Does that have anything to do with tarnishing? The dark coating, which is what tarnish is, it's when silver becomes discolored. So the dark coating is a new substance. Silver can be melted or tarnished, or no new substances are formed. So we're looking at chemical and physical changes. If silver changes color, what is that color?
The liquid silver.
Is it a dark color?
It is, yep, it would be B.
B.
It's actually a different substance. It is not silver. It's a reaction from, I believe, oxygen and something. When silver reacts, if you ever had a silver necklace or a silver coin, it tends to tarnish after it's touched. And that's because you have oils in your hands. And that reacts with the silver and it tarnishes. It's really interesting. And it's easy to clean. You can clean it off. It doesn't damage the silver, but it alters the surface. So it's a chemical change. It's kind of cool. Science is cool. All right, chemical reactions. We hopefully are a little more comfortable with these. Maybe. And let's see what, before we read, let's see what they want us to do. Which statement describes the chemical reaction represented by the three versions of the chemical equation? So we're looking for a chemical reaction represented by the three versions up here. And what they're talking about, three versions, they wrote it all out for the first one. Magnesium and oxygen turn into magnesium oxide. The second one, they used the symbols. The third one, they used an image. So these are all the same, just written differently. And which statement describes a chemical reaction represented by these? And we know it's magnesium and oxygen turn into magnesium oxide. So is magnesium oxide a reactant? Is it the product? Oh, sorry, yeah, that's magnesium. Is magnesium a product? Is oxygen a product? Or is magnesium oxide the product? And remember, when you're looking at these, your reactions are in the front, your product is behind the arrow. So magnesium, reactant, oxygen, reactant, magnesium oxide, product.
Is D. D.
It is D, perfect. Okay, I apparently am being called away because they're working on that bathroom. So what I'm going to have you guys do, go to, when you have some time, do page 49. Yeah, take a look at page 49, 50. You can try 51, see how you do, but we'll do 51 together. But try 49 and 51, see how that goes. And let me know if you have questions. You can always send your answers if you want some feedback. But science is pretty cool. And I'll get these pages scanned so you don't have the weird lines on them. All right. So is that good? Did you guys get something out of that?
Yeah, hopefully.
Excellent.
Yes, thank you.
Yeah, page 49 and 50. And we'll come back and do 51 and 52 together.
Okay, thank you.
Yeah. All right. Have a great day, you guys. I'll see you. Let me know if you need anything. I still need to send out the language arts stuff from yesterday. And I will do a video on the periodic table because I was supposed to bring that back, but I'll just do it on video so you've got it. There's like 5 things you have to know.
Okay.
All right.
Thank you.
Have a
Bye.
great day.
Bye.
Good
Have a great day.
day, everyone.